Hello, ladies and gentlemen, and welcome to the Triune Physics, aka Physics Bible. Today, we'll be dealing with one of the applications of Newton's law and conservation of momentum. One of the real life applications of the topic that we've been treating in our previous episode. The first will be the recoil of a gun. Of course, you must have seen the action of a gun before. We want to consider the realities of the action of a gun. So we term that to be recoil of a gun. So when a bullet is fired from a gun, what do you expect? The gun jerks backward, isn't it? It moves backward. So the gun is said to recoil. I hope you understand this concept. On the line recoil, please. Okay? So hence, Newton's third law of motion is in operation. We state that to every action, there is equal and opposite reaction. Exactly. So the forward movement or the forward momentum of the bullet, are we together? If you don't want to say movement, you can say momentum. Exactly. Of the bullet equals the backward momentum or movement of the gun. I hope this is clear. So looking at these, you must understand that there are key concepts. The triune component of the recoil of a gun include number one, the forces, both the reaction and the action, forward and backward reaction. Are you here? Then we have the movement, the forward movement and the backward movement by the gun and the bullet. Then we have the masses of the bullet and the gun itself. So we have force, we have movement, motion, momentum, and masses, M1 and M2. So let's take a quick break and look at the recoil of a gun in action. Exactly. Let's watch this game. Let's play it and see. Please stay tuned. We'll be back and we are going to prove the formula of a recoil of a gun mathematically. This is dead target interface. Okay, so we want to prove the idea of the recoil of a gun and also recall the principle of conservation of momentum. Are you here? If you observe this gun, you look at the gun jerking backward, right? Can you see that? You can see the movement of the bullet and that of the gun are in opposite direction to each other. Are you here? Now, you can see the arrows pointing directly to the action. This is slow motion, please, so that we can be able to explain perfectly what is going on. Then the triune components, look at it, the force through the trigger or by the trigger on the bullet, right here. Then there is a jerking. You can see the backward movement of the gun once the trigger has been pulled. So you can see that total momentum before collision is equal to total momentum after collision. But for these, before collision, everything is zero. Is that clear? Because both the gun and the bullet's initial velocities are zero. Everything is on standstill, which is static. Right here. So it is the final action that you are seeing. So based on these, we have what you are seeing being displayed on the screen. Are we together? So please, this action is to explain vividly the concept of the recoil of a gun, which automatically explains the concept of the principle of conservation of momentum. Is that clear? Killing spree. So what you've just watched is physics in action. Is that clear? So quickly, we are going to prove this mathematically. We're going to derive the equation for the recoil of a gun. Is that clear? So mathematical derivation or expression of the recoil of a gun. Are we here? If you observe, you see that we have the bullet, isn't it? Then we have the gun. These are objects of masses. So let the mass of bullet equals mb. Is that clear? Then let velocity of bullet equals v of b. Are we here? Then the mass of the gun will equal m of g. Are we here? Then the velocity of bullet equals what? Is it bullet or gun? Velocity of recoil of gun equals v of g. Are you here? Now if you observe, these tends to the final action or the final momentum. Are we here? For both the bullet and the gun. So m of b and v of b, you know, equals what? And then m of g and v of g also tends to what? If you understand this, then you can be able to solve problems. M of b and v of b is for bullet, and m of g and v of g for gun. And these are both the final momentum. Is that clear? Then for m of g and v of g, we have the source of the force. Is that clear? Then we have the bullet, which is the object, the recipient of the action. So for bullet, we have action. For gun, we have reaction. Then the effort is coming from the gun, and the bullet tends to be the load. Are we here? So please get this action and get the understanding here so that we can impute this into our formula. I hope you are following, please. So three things here: the mass of objects or the masses of objects, and then we have the forces of the two objects, and then we have their velocities, which equals motion or movement or momentum. So let's look at this gun. If you look at this gun now, you see that if we label this to be our gun, we label this to be our bullet. Is that clear? So you can see the directions are opposite to each other. So we have gun, we have bullet. Then let's depict the direction. The directions are opposite to each other. Is that clear? So note that total momentum before collision will equal total momentum after collision. Okay? Then, introducing this mathematically, MBVB is equal to forward or final momentum of bullet. Is that clear? Then MGVG will equal backward or final momentum of the gun. Is that clear? So, but recall that our initial momentum, okay, everything will equal 0 because MBUG, which is MBUB and MGUG will equal 0, please. Is that clear? Because both are stationary. Hence, MBVB will equal MGVG as our final equation. But we're going to prove this. Is that clear? We'll prove this. But this is the equation you will be using or that will be needed when solving problems under recoil of a gun. Is that clear? So let's prove this. Confirmation. Okay. Initial momentum is equal to 0. That is MB UB plus MG UG will equal 0. Okay, then MB UB plus MG UG will equal MBVB negative. Yes, negative MGVG. Is that clear? The reason is because they move in opposite direction. Is that clear? The bullet moves forward while the gun moves backward. Is that clear? So please take note of this part. So let's proceed further with this. Hence, we now have that 0 will equal MBVB minus MGVG. Is that clear? Okay. Therefore, MBVB is equal to MGVG. Okay. So this gives us our final equation. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.